Hello there, amazing people, amazing students, and all the lovers of chemistry out there. I'm so excited to be here with you once again on this episode on the series of stoichiometry in chemistry. I'm David, and all I do here is take the mystery out of chemistry so chemi can make history. Today, we're going to be talking about the concept of limiting reactants, theoretical yield, and percent yield. So, you want to stick around till the end of this video because it's going to be a jolly ride. So, sit back, relax, fasten your seatbelts, and enjoy all we have for you in today's video. All right, now, by way of introduction, it is important to know that in a chemical reaction, reactants combine to form products. However, in many cases, one reactant is usually used up completely first, while the others remain unreacted or left over. Now, the reactant that is completely consumed or fully consumed determines the amount of product that is formed and is called the limiting reactant. The limiting reactant is called that reactant that is used up in the course of a reaction while the other ones are left over. Now, the remaining reactants are known as excess reactants. Now, let me take one example that you can relate to explain what I just said. The limiting reactant is a substance that runs out first in a chemical reaction and it controls how much products can be made. Now, here is an example on the screen right now. Supposing you are making some sandwiches, right? And you have three slices of cheese, like it is illustrated here on the screen, and you have four slices of bread. Three slices of cheese and four slices of bread. Now, each sandwich you want to make needs two slices of bread and one slice of cheese. That is 2B, that's two slices of bread, and then 1C, one slice of cheese to make one sandwich. How many can you make? You will be only able to make two because by the time you get to the second sandwich, you would have used up four slices of bread, which is all the slices of bread that you had at the beginning. But then you will have one slice of cheese remaining. That means you can only make two sandwiches because the bread runs out first. Now, bread is the limiting reactant because it determines how many sandwiches you can make. And cheese is in excess because we have more than we need and there's extra cheese that is left over. So that's the concept of the limiting and the excess reactants. All right, so let's proceed further into what we have. An excess reactant. Now let's talk about the other concept, which is the excess reactant. An excess reactant is the substance that is left over or that remains after the reaction is complete. It is not fully used up. Now you can see on the screen right now, I have this illustration showing you the excess reactant and the limiting reactant. So what's next now? Let's look at some key points from what I just explained. The limiting reactant determines the amount of products that can be formed. The excess reactant is left over or remaining after the reaction stops. All right, now, so we're moving on to the concept of how to identify the limiting reactants. We've talked about some examples that you can relate to. Now, bringing it down to the concept of chemistry, how do you identify the limiting reactant in a chemical reaction? First, to find the limiting reactants, there are some steps that you need to follow. Number one, write the balanced chemical equation. Now, at this point, if you do not know how to balance a chemical equation, I have made an entire playlist to solve that problem for you. So just go ahead, subscribe to this YouTube channel, and go ahead and search for my playlist. It is there for you to learn all you can. So, step number one, write the balanced chemical equation. Now, look at this example. We have a reaction that shows the combination of hydrogen and oxygen to form water, and all the relative atomic masses of the individual elements have been shown. The next step you are to do is to convert the given masses to moles using the formula number of moles is equal to mass all over molar mass. Now, the question says, supposing we have 4 grams of hydrogen and 16 grams of oxygen. How are we going to know which one is the limiting reactant and which one is the excess reactant? First of all, we need to determine the number of moles, or we need to convert that mass 4 grams and 16 grams into number of moles. And how do we do that? Let's start with hydrogen. You can see on the screen here, we need to have the molar mass of the substance and we need to have the mass so that we can convert it into number of moles. For hydrogen, the molar mass is given by H2 and H has the relative atomic mass of 1.008. So therefore, H2 now becomes 1.008 times 2, which gives us 2.016 grams per mole. So therefore, if we want to convert into number of moles, we have the molar mass, which is 2.016 grams per mole, and we have the mass, which is 4 grams of hydrogen. And the formula says number of moles is equal to the mass divided by the molar mass. So what do? We simply say the mass, which is 4 grams, divided by the molar mass, which is 2.016, and that gives us 1.98 moles. The same thing for oxygen. The molar mass of oxygen is going to be O2. Now, O has the relative atomic mass of 16, so O2 will therefore be 16 times 2, which gives us 32 grams per mole. Now, the mass of oxygen that we have here is 16 grams of oxygen. So therefore, the number of moles will be mass, which is 16, divided by molar mass, which is 32, and that gives us 0.5 mole moles of oxygen. So now we've converted the mass for both elements into number of moles. What is the next step? Step number 3 says use the mole ratio to determine the limiting reactant. So what is the mole ratio? The mole ratio simply tells us the number or the proportion of the number of moles of reactants that are reacting. What do I mean? If you look at this equation now, you will see from this equation, we have 2 moles of hydrogen reacting with 1 mole of oxygen to produce 2 moles of water. So the ratio for this equation will now be 2:1:2 because we have 2 for hydrogen, 1 for oxygen, and 2 for water. So it is written explicitly here, the reaction requires 2 moles of hydrogen for every 1 mole of oxygen. 2H requiring 1O, that is 2:1. So now that we have the mole ratio, what does this tell us? Now, the next thing we have to do is to compare the available number of moles to the required moles. What do I mean? Now, we have been given the available number of moles. Now, let me backtrack a bit so I can show it to you. From this calculation that we did, we saw or we have seen that we have 1.98 moles of hydrogen available and we have 0.5 moles of oxygen available. We have the information of what we have on ground. So now we want to know what is required, because when we know what we have on ground and then we find out what is required, that will tell us if what we have on ground is enough. I don't know if you understood what I just said. We have 1.98 moles of hydrogen present and we want to know what is required. So when we find out what is required, it will now tell us whether hydrogen is enough or more than enough. So if hydrogen is now more than enough, we know that it is an excess reactant. But if it is not up to what we need, then we know it is a limiting reactant. So that is what we want to do right now. So now for hydrogen, we have 1.98 moles available, but let's find out what's required. From the equation now, which is 2H2 plus O2 giving 2H2O, we have 2 moles of hydrogen requiring 1 mole of oxygen. You can see there it is written 2 mole of hydrogen equal to 1 mole of oxygen. Now, we want to find out what is required. So we assume that we do not know the number of moles of hydrogen that is required. So that is why we say X moles of hydrogen. We give it an unknown variable. X moles of hydrogen will now require 0.5 moles of oxygen. Why did we say 0.5 moles of oxygen? Because what we have on ground, if you see over here, when we backtrack, we have 0.5 moles of oxygen available. So using that 0.5 moles of oxygen, we want to use it to find out how many moles of hydrogen that is required. So from here, when we cross multiply, X moles of hydrogen multiplied by 1 gives us X. It will now be equal to 0.5 multiplied by 2, and that gives us 1 mole of hydrogen required. So from this calculation now, we need 1 mole of hydrogen. We require 1 mole of hydrogen in this reaction. But from what we have on ground, we have 1.98 moles available. The question now is, if you have 1.98 and what you need is 1, do you have more than enough or less than enough? The answer is you have more than enough. So that tells us that hydrogen is the excess reactant. So now let's go ahead and check out for oxygen to see if oxygen will be a limiting reactant. Now for oxygen, we have 0.5 moles available, but let's find out, or let's see what is required. From the equation, 2 moles of hydrogen requires 1 mole of oxygen, or is equal to 1 mole of oxygen. So now let's announce, or let's assign an unknown variable to oxygen so that we can find out what is required. We have what is on ground, which is 1.98 moles of hydrogen, equal to or requiring X moles of oxygen. When we cross multiply, 2 multiplied by x gives us 2x, which is equal to 1.98. When we divide both sides by 2 to get x, that gives us 0.99 moles of oxygen. What does this tell us? It tells us that we need 0.99 moles of oxygen, but we have only 0.5 available, which is less than what we need. So therefore, oxygen is the limiting reactant. So we can therefore conclude that oxygen is what will determine the amount of product that can be formed because it is the limiting reactant. I trust that you understood everything that I've said up until this point. So now that brings us to the concept, or to the point of theoretical yield and percent yield. We have seen how to identify the limiting reactant and the excess reactant. So now we can now talk about theoretical yield and percent yield. Theoretical yield is the maximum or the highest amount of product that can be formed from the limiting reactant. Remember, the limiting reactant is the one that determines how much product can be formed. From the word theoretical, it shows, or it connotes, that the expected yield from the balanced equation, it connotes, or let me take that again. From the word theoretical, it connotes the expected yield from the balanced equation shown on paper for a reaction. Now, before the reaction took place, whoever the scientist was that was writing this out had an expectation from his calculation on paper. Now, that expectation is called the theoretical yield because it has not yet been practicalized. It is still in theory. I hope you understand. Now, here is the formula. The theoretical yield is the number of moles of product multiplied by the molar mass of product. Now, when you use this formula, the theoretical yield will be given to you in grams. The theoretical yield is equal to the number of moles of product multiplied by the molar mass of product. Now, look at this. From this question that we just solved, um, looking for the limiting and the excess reactant, if we are to be asked what is the theoretical yield, what we will have to do is to use this formula, the number of moles of the product multiplied by the molar mass of product. What is the number of moles of the product? We do not know, so we have to find that out. The molar mass of the product, however, we can do that here because we have the relative atomic masses of all the individual elements. For hydrogen, it is 1.008, and then H2 will be 1.008 times 2 plus oxygen, which is 16. So when you add all of them together, it gives you 18.016. So now that we have the molar mass of the product, let's calculate the number of moles for the product. Now, here is the equation. Remember, the amount of products formed will be determined by the limiting reactant. And we've determined the limiting reactant to be O2, or oxygen. Now, here is the equation. We found out that O2, or oxygen, is the limiting reactant with 0.5 moles available. So from the equation, we're using oxygen now because it is the limiting reactant that determines how much product can be formed. 1 mole of oxygen produce 2 moles of H2O, or water. So therefore, we have 0.5 moles of oxygen available. Remember, when we calculated the number of moles of the reactants, we we found out that it was 0.5 moles that was available for oxygen. So 1 mole of oxygen produces 2 moles of water. How many moles, therefore, will 0.5 moles of oxygen produce? When we cross multiply, it will be x multiplied by 1, x moles of H2O multiplied by 1, and then 0.5 multiplied by 2. So therefore, we have 1 mole of water being produced. Now we have the number of moles of the product and we have the molar mass of the product. So therefore, we can go ahead and use this formula that says theoretical yield is equal to number of moles of product times molar mass of the product. So now theoretical yield is equal to number of moles of product times molar mass of product. Number of moles of product is 1 and the molar mass of the product is 18.016. So therefore, the theoretical yield of water is 18.016. That is the yield that has been written on paper, what we expect, and the maximum amount of product that can be formed from the limiting reactant is 18.016. I hope you are following. Now, that brings us to the concept of percent yield. In real life reactions, the actual yield is often less than the theoretical yield due to side reactions, loss of material, or experimental errors. Percent yield measures how efficient the reaction was. Now, when you write out your processes on paper, everything that is supposed to happen when you get into the laboratory, it doesn't always turn out the way you expect. There are some experimental errors, some losses of materials, and so many factors that I may not be able to mention in this video. But what happens at the end is that you find out that what you actually get in real life is a bit less than what you envisage that you were going to get on paper. So that is why percent yield is very important. It tells us how efficient the reaction was. It tells us how close we came to the theoretical yield. Now, to get percent yield, there is a formula. It says the percent yield is equal to the actual yield, what you got in real life, divided by the theoretical yield multiplied by 100%. Now, if we are to calculate the percentage yield of this chemical reaction, we have to have the actual yield and the theoretical yield. So the question says, supposing we obtain 15 grams of H2O instead of 18.02. Now, remember, the theoretical yield that we just calculated in the previous example is 18.016. That's the theoretical yield. So now they're asking us that if the actual yield, what we actually obtained was 15 grams, how do we get the percent yield? Simple. We divide the actual yield by the theoretical yield. Actual yield is 15, so we say divided by the theoretical yield, which is 18.016 multiplied by 100%. That gives us 0.833 times 100. That is 83.3%. That tells us that the reaction was 83.3% efficient. So in summary, what have we said so far in this video? The limiting reactant determines how much product can be formed. Excess reactants remain unreacted after the reaction stops, and theoretical yield is the maximum amount of product expected. Percent yield compares the actual product obtained to the theoretical yield. Understanding this concept is essential for predicting reaction outcomes. At this point, we've come to the end of today's video where we've talked about theoretical yield, percent yield, and the limiting and excess reactants. I want to say a very big thank you for sticking around till the end of this video. If you enjoyed it, please do subscribe to my YouTube channel, like this video, and turn on the notification bell icon so when more educational stuff like this come out, you'd be the first to be notified. Until I come your way next time, my name's David, and all I do is take the mystery out of chemistry so chemi can make history. Thank you.